A single blade moving just a fraction of an inch too far can destroy 50,000 hot dog buns in under an hour. One microscopic mechanical error. One sensor failure. One mistimed cut. And suddenly an entire factory producing millions of buns for America's biggest food brands grinds toward disaster. Yet every summer, while families fire up backyard grills and baseball stadiums sell thousands of hot dogs per game, an army of machines performs one of the fastest, most precise, and least appreciated engineering feats in modern food manufacturing. Hidden inside massive bakeries, automatic bun slicing systems are making thousands of perfect cuts every minute with an accuracy measured in fractions of a millimeter. And the shocking part is that most people never realize these machines even exist. Picture this. It's 2:43 in the morning inside a bakery larger than several football fields combined. Conveyor belts stretch into the distance. Thousands of freshly baked hot dog buns glide through the facility in endless rows. The smell of warm bread fills the air. Everything appears calm. Almost peaceful. But beneath that calm surface, a race against time is underway. Because every bun moving through this factory has exactly one chance to be sliced correctly. Too deep, and the bun falls apart. Too shallow, and customers can't separate it. Too much pressure, and the bread becomes crushed. Too little precision, and entire shipments become unusable. And here's where the mystery begins. How do factories make millions of identical cuts every day while moving at speeds impossible for human workers? The answer lies inside one of the most fascinating pieces of food engineering ever developed. Most people imagine bun slicing as a simple process. A blade cuts bread. End of story. The reality is far more astonishing. Imagine trying to slice thousands of soft, freshly baked buns every minute. Each bun is slightly different. Some are taller. Some are wider. Some contain more moisture. Others cool at different rates. Yet customers expect every package to look identical. That's the challenge engineers faced. And what happened next changed the baking industry forever. The first obstacle wasn't speed. It was softness. Fresh bread is surprisingly difficult to handle. Unlike metal, plastic, or wood, bread constantly changes shape. Press too hard and it compresses. Move too quickly and it tears. Cut incorrectly and it collapses. Now consider a factory producing hundreds of thousands of buns every day. Suddenly, a bakery becomes a mechanical engineering laboratory. Every bun transforms into a moving target. And that's where the real innovation began. Engineers realized the blade wasn't the most important component. The positioning system was. Because before a bun can be sliced, it must be perfectly aligned. Picture thousands of buns racing down a conveyor belt at astonishing speed. Specialized guide rails gently adjust their position. Sensors monitor spacing. Optical systems verify alignment. Every bun is nudged into exactly the right location before reaching the cutting zone. But that's not the craziest part. The machine often has only fractions of a second to make corrections. A delay invisible to the human eye can affect thousands of products. This is where automation becomes extraordinary. Advanced sensors continuously monitor production. High-speed cameras capture information faster than humans can process. Computer systems analyze bun position, shape, spacing, and orientation in real time. Imagine blinking. Now imagine a machine making dozens of calculations before your blink finishes. That's the level of speed involved. And it gets even more impressive. Because cutting bread isn't really about cutting. It's about controlling force. Too much force destroys the product. Too little force creates incomplete cuts. The blade must move with extraordinary precision. Engineers spend years refining these systems because the margin for error is astonishingly small. In some facilities, blades operate continuously for hours while maintaining nearly identical performance. Thousands. Tens of thousands. Sometimes hundreds of thousands of cuts. Every single day. And yet the most fascinating challenge isn't the blade itself. It's the bread. Because bread is alive in a way most people never consider. The moment buns leave the oven, they begin changing. Heat escapes. Moisture migrates. Texture evolves. Density shifts. What feels like a simple piece of bread is actually undergoing constant physical transformation. And every change affects slicing performance. Now imagine managing those variables at industrial scale. One batch emerges slightly warmer. Another slightly cooler. One production run contains higher moisture levels. Another behaves differently because of humidity. Suddenly, engineers aren't just building machines. They're controlling a dynamic biological process. And that's when the billion-dollar engineering race began. As demand for packaged buns exploded across America, bakeries needed more speed. Baseball stadiums. Theme parks. Convenience stores. Fast food chains. Supermarkets. Every customer demanded consistency. Every retailer demanded efficiency. Every second saved translated into enormous profits. Competition intensified. Machine manufacturers began searching for ways to push production even faster. What they discovered was remarkable. The limiting factor wasn't always the blade. It was airflow. Yes, airflow. Imagine thousands of buns traveling